In this tutorial, I want to start some calculations involving Kc. If you are a higher student of IB, this is good for you. If you're standard, you really don't need to calculate. You can relax and ignore this video. So the first question is rather, you have an equation of hydrogen mixing with chlorine. There is double arrow equilibrium produces hydrogen chloride at given temperature. It's important that the temperature to be given to us. So it's specific at 500 degrees Celsius. Then there is another piece of information. Equilibrium concentrations, which are mole per decimeter cube, are given. Hydrogen is 0.18, chlorine is 0.39, and hydrogen chloride is 1.95. What is a value or magnitude of Kc equilibrium constant? So Kc, we write the expression, which is products. In this case, you have hydrogen chloride raised to its coefficient 2 divided by reactants, hydrogen exponent 1, chlorine exponent 1. These are all at equilibrium, so they all have subscript of EQ, and that's where you find Kc. So let's just plug in the numbers we have. Concentration of hydrogen chloride is 1.95 squared divided by concentration of hydrogen, which is 0.18, multiplied by concentration of chlorine. And if you do the calculations, you will get 54. So that is your equilibrium constant at 500 degrees Celsius. Now let's look at another related question, question number 2. Same reaction, hydrogen chlorine, same temperature, and now this time they give you concentration of hydrogen at equilibrium and chlorine, and concentration of hydrogen chloride is challenged. What's the question mark? Then I wrote here Kc is 54. Where does it come from? Since it's the same equation, same temperature, we just solved it on the previous slide. So 54 is the value of Kc. If that's the case, let's just write it. Kc equals 54, a number, equals to products, HCl raised to power 2, divided by reactants at equilibrium. This time I just plug in numbers if you don't mind. So 0.25 for hydrogen, 0.50 for chlorine. Then let's just see what happens. So hydrogen chloride squared is equal to 54 multiplied by 0.25 multiplied by 0.50. Now let's just simplify it. So HCl squared at equilibrium is simply these three numbers being multiplied, which I just calculated, is 6.25. Now what is HCl? HCl at equilibrium is concentration is simply square root of 6.25, which happens to be 2.5 mole per decimeter cube. So that's equilibrium concentration of hydrogen chloride.